A triggered jog move, again, usually will be a homing move, but it could theoretically be just about any sort of jog move that you want to change based off of an input. So if you have a limit switch on your system and you want your motor to jog in a certain direction until you hit that limit switch and then back off by a little bit, that'd be a perfect example for a triggered jog move. Alternately, if you want it to continue to jog until a status bit goes true, or a register that you're calculating something in, or just an input from a different system goes true, and then you want the system to either stop or move differently or something like that, triggered jog moves are really where you want to look to figure out how to do those. There's two types of triggers that you'll be using, which are going to be input triggers, typically either an encoder index or a flag input to the system. And then there's an error trigger, which is the warning following error. If you exceed that, then that gets triggered. So just to stick on that for a second more, we have already 4 flags. We have already a couple flags built into PMAC that are already determined in the registers. There is a home flag, which on all these boxes is one of the 3 switches on the right side of your box. There's 3 switches per motor. There's a home flag, which could be tied to a limit switch that you want to home your motor to. There's an M limit or minus limit, negative limit flag that is a negative limit switch. You typically want to have that at the absolute negative most point on your system, offset by a little bit, so that if you ever hit that switch, you know that you're about to smash into something. You'll have that just as a hard stop, basically. There's a positive limit switch, same idea, but on the positive end, make sure you don't run a linear stage right off the track or smash your tool into something. And then there's a user flag, which is just a general purpose flag. We have the register for it. So if you want a home and you want a second homing one, or if you want to have a second sensor you just incorporate in this and you want it to control the motion, you typically wire that into your user flag. In addition to those 4 flags, many encoders, though not all, especially incremental coders, may or may not have this, have an index pulse, where in this case we have a quadrature encoder, which has 2,000 counts per revolution, and then once per revolution it has another count that will toggle high for a pulse. So that encoder index flag tells you where in a single revolution you are by telling your proximity to that flag. Because of that, for rotary motors like this that we don't have any tooltip on, it's completely symmetrical all the way around it, we'll typically home to that index, that encoder index input, because when that goes high, we know we're aligned at a specific spot in the encoder. It just gives us an easy, repeatable signal to home to. Now, there are 3 methods of capturing that signal. What happens is when PMAC sees that signal go high, whatever type of signal it is you choose to use, it will immediately try and capture the current motor position, so it knows whatever action you want to do is based off of where the motor was when that signal went high. There's hardware capture, which is going to be the least flexible but most accurate one. That doesn't actually use the PMAC CPU directly. It goes entirely just through the access card, and it gathers the value basically at the encoder clock, which can be up to 100 megahertz. So it'll be your fastest, most accurate one. It grabs the encoder position at the instant, as close to it as we can get, that you trip that flag, and it's going to be therefore most accurate in that regard. But because it doesn't use PMAC, you can't get any processing from it. You have to access it in the raw units of the register, and it is a little bit harder to use because of that. There's software capture, which may be delayed up to 1 cycle because you're letting PMAC do the processing on the raw data. Because PMAC is doing the processing, you have to give it time to do the processing, and as such, it will be a little bit slower. And then there is the timer-assisted software capture, which is technically another form of software capture, but we do some interpolation to try and make it more accurate. Now, there are 3 different types of triggered moves. We'll basically be dealing with a homing search move, which is by far the most common. The other 2 are online jog until triggers, so you jog until you get a trigger, and program move until trigger, which you guys will deal with tomorrow, but for all intents and purposes, it's the exact same thing as the online jog until trigger, with the caveat that it's being commanded to an axis and it's being done in a motion program rather than being a jog move. Again, when you guys learn motion programs, you'll see it really is identical to it, so I'm not going to spend much time right now, but it'll be covered a bit more tomorrow. So for triggered moves, these are the relevant parameters. This one's actually a typo. It's not supposed to be there. There is no capped flag. I apologize. I caught that this morning after we'd already printed everything out. So there's capture mode, which determines what type of trigger you'll use. There's capture control, which determines whether you're using a flag, whether you're using your index pulse, whether you're using it when the index pulse is high versus low. It's basically what you're looking at, what signals you expect, and what the polarity of those signals you expect. There's capture flag channel, which is only really used in software. Basically, it allows you to look on motor 3 for a flag that's coming in for motor 2. So when a flag on motor 2 goes high, motor 3 will respond to it. And there's capture flag select, which determines which of those 4, home flag, minus limit, positive limit, and user flag, which of those 4 flags is the one that you'll be using if you choose to use a flag. So, to step through the 4 different options for capture mode, the first one, if you have capture mode equal to 0, is going to be your immediate input trigger. It is the fastest one to respond. It is entirely done in hardware. So, when the trigger goes high, when we get that response, PMAC will look at motor.pcappedPause. PcappedPause will tell PMAC where it's getting the motor data from, and generally it will point to gate3.chan.homecapped.a. That will be inside of that address, raw data just coming in directly from the encoder, and the units for it are 1/256th of an encoder count. So if you want to use that value, if you're using your hardware trigger, your capture mode equals 0, and you then want to use the value you're getting from that in a future calculation, you need to scale it by a factor of 1 divided by 256 to account for the fact that the units of the raw encoder data are not in motor units outright, they're not in encoder units outright, they're in a scaled version of that. So you'll use capture control still, because even though it's hardware, it is faster. You can still choose to go off of your encoder index pulse or a flag or a combination of the two. So use capture control to determine what you're actually looking at, and then depending on your value of capture control, you may need to set cap flag chan or cap flag select. Again, because this one's going through the hardware, it's not going through all the processing, your cap flag chan is going to be somewhat useless. You are going to have to look at whichever channel of the motor you're planning on triggering. If you're triggering motor 3, you have to look at that channel, but you do need to make sure it's still set properly. If not, PMAC may get a little bit upset with you. Cap flag select is really more of the key one for that, because that's which flag you're looking at. The next mode is if capture mode is set to 1. If it's set to 1, it will be a software capture input trigger. For this one, rather than looking at that gate.chan.homecap.a, it looks at motor.actpause.a. This is already scaled for you. It's already in your motor units, so it's easier to use. Again, it is delayed a little bit because PMAC has to process it, but it's easier for you because you can just use the motor units directly. You can multiply that or compare that register directly to a motor value that you want. Again, same thing as before. Use capture control to select what kind of trigger, and use cap flag channel and cap flag select to determine what actual exact flags you want to look at. Next is the following error trigger. For this one, we actually don't use any flags at all. What happens is PMAC will just move the motor until it determines that the following error is building up too high. So this is a bit weird. Basically, the idea is if you want to home a motor to a hard stop, or if you want to jog a motor to a hard stop, you set the speed way down, make sure you're not going to smash into it full blast, and then you just jog it indefinitely in that direction with capture mode set to 2. Eventually, you'll hit the hard stop, and when you do, obviously the motor won't be able to move anymore, but PMAC will still be trying to move it. So your following error will slowly count up at whatever rate determined by your jog speed. When your following error gets equal to your motor.warn following error limit, it will trigger and do whatever it needs to do. So if you don't have any limit switches for whatever reason, and you need to home this some other way, you can home it to the hard stop. Again, make sure you don't go too fast, because this is assuming you will crash. You have to crash in order for this one to work, but in a controlled manner, hopefully. And at a certain point, when your trigger goes off, your value will be, again, motor.act pause, so you'll have it in motor units. It'll be easy to work with at that point. The last one is a cross between the first two, really. It is technically a software capture, so you have the flexibility of that. You can look at different channels. You can actually combine flags. If I want a flag for motor 2 and a flag for motor 3 or something like that, you have the full flexibility afforded to you by using software capture. But PMAC will then go and look at when the flag got set, and it will try and interpolate backwards to give you a more exact value. In general, I would probably recommend you use this one over setting equal to 1. Use the timer-assisted software capture over just the normal software capture. But I will note, however, that this is an interpolation, so PMAC is making up some of the data to try and fill in for what the data actually was that it lost because it's using software capture. So there's a slight chance, just as a disclaimer, that it is inaccurate in that regard, but more often than not, I would imagine, it's effectively a more accurate version of setting capture mode equal to 1. Same parameters are relevant. Actual position register, motor.act pause is where you're looking, so your values will be in motor units. You want to set capture control, you want to set capture flag channel, and capture flag select. When you're homing specifically, there's two other parameters that matter: home offset and home velocity. And I do apologize, I will stop talking about this soon. We're, I think, almost done with this section. Home offset is basically if you're homing system to a homing flag, or if you're homing to a hard stop, you may want to hit the flag and then back off by 1,000 counts, 2,000 counts, some number to get you to a known position such that your flag isn't being held down, you're not smashing into your limit switch. For that, you can set a value in home offset, and your motor will home until it sees that flag, and then it will set the actual home position to be wherever it saw that flag, plus or minus your home offset. Home velocity determines the speed at which you try and home, or the speed at which the motor moves when you issue a home command. Especially if you're homing to a hard stop with the following error limit, you want to make sure this is set fairly low. Even if you're not homing to a hard stop, you probably want to set it low just so that your PMAC, your motor doesn't go smashing past the limit switch and somehow not hit it enough anyways. So, a move command, the general form of a triggered move command would be something like this. If you're homing it, if that's the type of move, it'll be #N home. Just tell PMAC what motor you're addressing and then type out HOME home, and it will home the motor. If you issue that right now, by default on the boxes, they're all set to home to encoder index pulse, so you should see the motor spin around less than one full revolution, and then it'll stop. For a triggered jog command, it is whatever your normal jog command is, followed by a caret, followed by another constant. What that says is, I want you to follow whatever jog command I'm issuing. However, if somewhere in the execution of that jog move you see this trigger go true, then I want you to move this far away from the position at which the trigger went true. So if you issue #J equals 10,000 caret 0, that says I want to jog motor 1 out to 10,000 counts, unless I see the trigger, in which case I want to bring the motor back to wherever it saw the trigger. If you issue J equals 10,000 caret -2,000, similarly, jog out to 10,000 unless you see the trigger. If you see the trigger, I want you to move 2,000 counts before that trigger occurs. So if it triggers at 5,000, your motor will end up stopping at 3,000. The last one down here, again, it's equivalent to this one up here, but instead of issuing a jog command, it's issuing an axis command. The general format for an axis command, just to jump ahead a little bit, as it says here, is axis data caret data. So if you're commanding your x-axis to move 10 units, that would be x 10. However, if you get your trigger, you want it to move 3 more units, caret 3. For that, you're using a motion program in a coordinate system with axes defined, and PMAC will interpret that as a move of the x-axis 10 units, either absolute or incrementally, depending on how you have it set up. And then If it sees the trigger, it instead moves it 3 units incrementally to that trigger. So, unlike the last one where we had the J plus indefinite followed by a J slash, this one's using a home command or any of the other triggered move commands. And one thing right off the bat you should notice is that we have a large purple section here in which the motor sees a trigger, slows down to a stop, and then continues negatively until it ends up at a velocity of 0. The reason for that is, unlike that J slash where you just bring the motor to a stop, with any of these triggered jog moves, the final portion of the move is with respect to the location that it triggered. What that means is, this beginning part here is the exact same as that jog graph, but at this point we see a trigger, so we're homing the motor, and we see the home flag goes true. Rather than coming to a stop, PMAC comes to a stop as quickly as it can, as quickly as is allowed, and then actually will back up and go in the opposite direction until the integral of this is equal to the integral of this, and your motor is at the position that it was when the flag went true. So looking at the status bits for this one, we see when the home command is issued, home complete is not true. Obviously, we're not homed yet. Home search in progress is true because we are looking for our home. And trigger move is true because this move has a trigger condition to it. We then have our S curve, our constant acceleration, our S curve out, and then we move at either our jog speed if we're using a triggered jog move, home speed if we're using a homing move, or potentially either max speed or jog speed if we're using a rapid move. Again, that's for the triggered axis move. So we'll continue moving at our jog speed or at our home speed for an indefinite amount of time until we see the trigger. See the trigger, depending on what kind of capture we're doing, we'll have some slight delay because if we're doing software, we'll have that one cycle that it's doing calculations, and then it will begin to decelerate. The instant you see that flag, home complete goes true, trigger move goes false, and home search in progress goes false. As soon as it sees that trigger, even though the motor is still moving, PMAX says, okay, I know where my home position is. I know where I need to go if someone tells me to home. I know where all of my moves are with respect to. I know where my home is, so the home search is finished and the home is complete. It will then continue to decelerate, go negatively, again, go at max velocity but in the negative direction, or your jog speed in the negative direction, or your home speed in the negative direction. And then it will go to a velocity of 0, at which point we'll still see all three of those status bits up there remain the same, but desired velocity 0 bit will go true as we have finished our full home search and we want to be not moving anymore, and we are in position because in position is true. So to search for a home move to successfully complete, just if you're setting up a new system, you want to have some safety checks. If I issue a home command, I want to make sure it actually is homed. You can look at the home complete bit, you can look at the in position bit, and you can look at the desired velocity true bit. Once all three of those are true, your motor is stopped in the position commanded to it while it knows where its home value is. Now that we've gone over that, I want you guys to go through these 3 exercises. Basically, I want you guys to home your motors based off of 3 possible conditions. These are all going to be based off that capture control possibly, and which one was it? No, capture mode and capture control mainly. I want you guys to home your motors to the home flag and the index pulse on the encoder. I then want you guys to home it to the negative limit flag and the index pulse on the encoder. And then I want you to home it once to the warning following error. For that one, just grab the motor slightly whenever you want, and the motor should home when it sees that it's hit a hard stop, your hand. For this second case in particular, because you're homing to the negative limit switch, as of right now, on your boxes, that negative limit switch is actually set as a negative limit switch. If you are jogging the negative direction and you flip that switch, PMAC will immediately stop the motor because it's hit the switch. It can't go any further. So you'll need to disable your limits by setting motor.plimits equal to 0 to do that one. And then when you finish that one, re-enable your limits by setting motor plimits equal to gate.chan.status.a. So look up those parameters. I'll write them up on the board here again. And I want you guys to home with those 3 different commands. One new thing to Power PMAC that I do apologize if you guys have been running into issues with this, whether or not you realize you're running into issues with this. One of the newer things in Power PMAC is that some status bits are write protected. And the reason for that is many, but in general, we don't want a user, an end user, to accidentally go and mess with system parameters, accidentally change the clock speed on the entire thing, and set a watchdog and break the machine, require an integrator to have to come out and fix it. So the solution we came up with was to make some things write protected. Unfortunately, for the training class in particular, in which we're going and messing with all these parameters to learn what they do, the result of that is we need to know to tell PMAC to allow us to edit parameters. And I didn't mention it, I forgot to mention it, it's not in the slides. So anyone who thinks that they got everything to work properly, I question whether or not you did, because I know that right now if I'm setting capt control equal to 15 and then query my capture control, I see that it's still equal to 1. So unfortunately, that's one of the write protected parameters. If you ever try and change a gate 3 parameter, it's very important to check what the actual value is after you change it, because you'll find fairly often the gate 3 parameters are write protected and you're not able to change them. The way to change them is, in a motion program, you either throw this line at the very top of the motion program or PLC or whatever you're downloading. In the terminal window, you enter this command once and it will continuously take effect for that boot. If you power cycle your drive, you'll need to reissue it. But sys dot write protect WP key, if you set that equal to $AAAAAAAA, so 8 A's in a row, you will now actually be able to change those parameters. So capt control is equal to 1. I'm going to set it to 15 and query it again, and we now see it actually did in fact take the value 15. I do apologize for that one, honestly. It's my fault for not having caught it sooner, but it causes problems when you're trying to change how you're homing, because you're issuing the commands and you don't think to check it, and PMAC echoes your command back at you, so it looks like it has taken hold when it hasn't. So now that I've set that, and I'm going to write it on the board really fast here. Set sys.writeProtect key to 8 A's in a row, or a $ followed by 8 A's in a row, and you'll actually be able to change those parameters. Going back to my box here, so I'm setting my capture control to 15. That, as we see from here, sets it to capture on both the index high and the flag going high, as opposed to the default value of index. Then I want to look at the home flag. Which is the default value of 0. So now, if my flag's low and try and home motor 1, we see motor 1 is just continuously spinning, 40,000 counts, that's 20 revolutions, and it's just going to continue spinning indefinitely at the home speed of 10 motor units per millisecond until I set the home flag high by flipping the switch up here. As soon as I flip the switch, we see it finishes. It finally saw my home flag go high, and within one revolution, it sees the index of the encoder go high also. And as soon as it sees both those statements as true, motor is homed. So that's the first one, and if anyone is having difficulty, set your sys.writeProtect key and then try again, and chances are it'll all magically start working because you're actually able to set the values. We have a request just to explain kind of the hierarchy of the commands. So I'm telling you guys to issue motor.stuff and gate.chan.stuff, and figure it's as good a time as any to explain a little bit about what that actually is. So first, motor, fairly obvious. Wherever you see motor X dot something, that says the scope of this command here is a single motor. It is usually directly related to the motor, so a jog speed or an acceleration time or something like that. It's tied to the motor, and it's very specific to the motor itself. The next one is sys, like that sys.writeProtect key we just dealt with there. That is the general system of the PMAC. You may have clock stuff there, you may have a couple of different commands depending on what it is you're trying to do, but that is the entire system. That is very rarely will you actually ever need to change those values. If you're good with your default values, you never theoretically need to use them, but if you want to change something for a custom application, you may go into sys commands on startup on the first time you're building up the system. Those will be the first ones you'll set. Now the gate 3 is one of the chips on many of our cards. In this case, you guys are using a piece of hardware in your UMAC rack called a 24E3. It's the one that has these 4 big bulky connectors coming to the top of it and these 4 smaller terminal blocks coming to the front of it. And it is the axis control card. What that means is it's the one that's actually controlling the axes that can have motors or may not have motors on them. They can have some flags. They can have an encoder conversion table entry pointed at them. It's the general spot where most of the motor organizational stuff happens, is your gate accessories. Now, for this specific PMAC rack, the actual hardware you have is a 24E3, and just to let you guys know this, you actually never need to issue gate commands if you don't want. You could just issue accessory 24E3I. Because in the PMAC, if you issue this command, the IDE will actually remap it to be this command here. So whenever you see gate 3, that means you are addressing a gate 3 accessory. Typically for a UMAC, it's accessory 24E3, but depending on what your hardware is, if you're using a power brick LV, power brick AC, power brick controller, any of those, the boards inside of them have gate 3 chips on them. So Power Brick 0, for instance, or Power Brick I also remaps to gate 3. Asked one of our software guys because I was curious if for some reason you have multiple gate 3 accessories on the same system, such as accessory 24E3 somehow in addition to a power brick, they are distinct items. If you were to try and issue right now Power Brick 0, expecting it to remap to gate 3 and therefore be the exact same as this, it wouldn't work because PMAC sees there's no power brick present. But the point is, all gate 3 means is it means this command is going to go to an axis card of our newest hierarchy, which is gate 3. If you're using some of our older systems, such as an accessory 24E2A, it's the older version of the 24E3, that would be typically a gate 1 device. Additionally, there's gate I/O, which is for I/O modules sometimes, again, generally older ones, and there are some gate 2 accessories, though they're fairly few and far between. So generally speaking, in Power PMAC, you'll either address gate 1 or gate 3 whenever you're doing anything that deals with motors or flags. Now, for all of these, one of the most common next parameters will be .chanj. In the axis card, you have axes. For a 24E3, it's generally a stack of actually 6 boards make up the device. There's 2 main boards. Each of them have 2 daughter boards on the top, and each of them has 1 daughter board on top, 1 daughter board on the bottom, for a total of 2 ports per daughter board, 4 ports on the top of it, 4 ports on the bottom of it, plus however many flags in the front. Whole bunch of stuff to it. Basically what it means is that a single stack 24E3 is 2 axes of motors on its own, and the full stack, which is the 6 board thing we have here, is 4 axes. Each of those axes is considered a channel. So when you issue gate 3.0, the first gate 3 device you have in your UMAC, the first gate 3 device that's going to be addressed by this CPU, .chan 0, you're saying I want to look at the first channel on the first board of that first 24E3 or of that first gate 3 device. So all of your motor commands on the PMAC side are going to be going through gate3.chan. Whatever command it is. On the motor side of it, it will be motor more often, but if you're doing some masking, for instance, you need to mask your commands because you're using a specific amplifier and it wants an ADC mask like that. You'd issue your command to the gate and the channel that is controlling that amplifier. So when we're setting gate.chan.capped flag select, that's saying I want to look at my first gate 3 device, if I'm issuing gate 3.0, which is that 24E3. I want to look at my first channel of it, if this is 0, so that first channel on the first main board. And then I want to look at how that specific channel is going to deal with the flags, which flag it wants to look at. So it all kind of comes back down to the hardware eventually, and the gate.chan parameters all refer to this board right here, or these 2 boards right here, your accessory 24E3.